The lesson today is about precision and accuracy. Now these are two words that a lot of times are used interchangeably, but in science and chemistry it's really important that you know the difference. So we're going to go through and look at the difference between the definitions. I'll give you some examples to help, and then I'll show you how to actually calculate to find out if you are accurate or not. We'll do that with percent error. Okay, so let's get started. First of all, precision. Precision is how reproducible your data is. So if you look at this graphic, it's a target with a bullseye in the middle. The four black dots that you see on the upper right corner are the shots that this person has made. They landed on the target every time, so they were repeating their results. They just weren't getting very close to the bullseye, which is the expected result. So for this diagram, we would say that these results are precise. They are reproducible and repeatable, but they are not accurate. So what's accuracy? Accuracy is how close your data agrees to like an accepted or a given value. For example, this bullseye, the four dots are centered around the bullseye. So the person has hit the bullseye every time, or sorry, near the bullseye every time. So they're really close to the accepted answer. They're accurate, but in this case they're not precise because they didn't hit in the same area of the target every time. Make sense? Alright, so here are four for us to consider. The top left bullseye has precision, but not accuracy. The top right has accuracy, but not precision. Those are the two that we just looked at. So now let's look at the two on the bottom. Bottom left, 4 shots in the red bullseye, center of the target. That is both accurate and precise. They got the right answer and they repeated it 4 times. The bottom right bullseye, you notice there are 4 in the center of the target, but there's 1 to the left in that green band of the target. So because of that, this person has decent accuracy, but they're not very precise because of that 1 that's kind of out of the area that they should be in. Now sometimes this can happen to you in lab. And if it does, it's acceptable at the end to throw out data that you think is wrong. If it's not going to help you and it doesn't agree with the rest of your results, it's okay to get rid of it. Alright, so let's talk about how to deal with this in lab. When you go into lab, you need to study your equipment before you start. Different types of glassware have different scales on them, and different types of balances have different capabilities. Some can read to the tenths place, the hundredths, the thousandths. You have to decide that before you start using the equipment. Now the rule is going to be this. Write down every number from an instrument that you know for certain plus 1 uncertain digit, and that's when you stop. By using this system, it lets other people know how many decimal places you think are correct when you've made your measurements. Alright, so let's look at some of these examples. On the top left, the first one is a beaker. And if you look, the scale that's on this beaker is in increments of 10 milliliters each. So I know for sure that this blue liquid is between 40 and 50 milliliters in volume. So I'm going to write the 40 down for certain, and then I'm going to guess at the ones place. So I've guessed 48 milliliters. If you guessed 49 or 47, we would all be correct. Alright, bottom left. This is a graduated cylinder, and it looks like the scale on that graduated cylinder are tenths of a milliliter, 0.1 milliliters. So I know for certain that this blue liquid, reading from the bottom of the meniscus, is between 20.3 and 20.4 milliliters. So I would record the 20.3 milliliters because I know that for sure, and then I'm going to guess at the hundredths place. So I guess 20.39 milliliters, and that's my recorded value. Last one, top right. This graduated cylinder has a different scale. It's in 1 milliliter increments. So I know for sure that this blue liquid, when I read the bottom of the meniscus, is between 36 and 37 milliliters. So I'm going to write down the 36 milliliters for certain, and then I guessed the tenths place. So I recorded 36.4. Alright, so I hope that that helps you. I hope that when we go into lab you'll be able to look at all of your equipment and to figure out the best types of numbers to write down, and you'll know how many to write down. Now, measuring accuracy and doing good lab procedure is great, but we also have to have a way to calculate how accurate we are. We're going to do that with the percent error calculation. Now, the formula for it is here. It's the experimental value, which is what you get in lab, minus the actual value, which is the accepted answer, and then you divide that by your experimental value. We want it to be a percent, so we're going to multiply that answer by 100 to get the percent answer. The trickiest part about using this formula is deciding which number is the experimental value and which number is the accepted value, or the correct answer. So be really careful, especially when you have word problems, that you can pick those two numbers out. Alright, well, good luck with that. A lab is coming very soon, so you'll get a chance to put all of this to practice then. See you next time.